Hello and welcome to your Chapter 11 video lecture series where we're going to talk about the axial and appendicular muscles. So first let's differentiate axial and appendicular muscles. Our axial muscles are going to have both origins and insertions on the axial skeleton. If you remember, that's going to consist of your skull, that hyoid bone, your vertebral column, the sternum, and our thoracic cage, so the ribs as well. And by having these muscles attaching to those bones, we give support to those structures and can move the head and vertebral column. And we are also going to be able to function in facial expression, breathing, chewing, and swallowing, and can support and protect the abdominal and pelvic organs. Now, our appendicular skeletons are going to control movement of our upper and lower limbs and control movements of our pectoral girdle and the pelvic girdle. And this is organized into groups based on their locations. Now let's go ahead and start with section 11.1 on skeletal muscle composition and actions. And we've mentioned some of these terms before in our joint lecture, but a tendon is going to attach the muscle to the bone, or it can even attach to skin or another muscle. And we've seen this term aponeurosis before as well. This is a flattened tendon that is similar to a sheet or sheets on layered on top of one another, like we see with the oblique muscles over here. And most of the muscles in our body are going to cross at least one mobile joint. And when we contract that muscle, one bone is going to move while the other one stays fixed. So we are going to talk about where these muscles are going by referring to them as attachments. So our attachments for our axial muscles are going to have a superior attachment, which is going to be more movable, and the inferior attachment will be less movable. Whereas our attachments in our appendicular muscles, we will have a proximal attachment like we see here with the biceps brachii, and a distal attachment which is more movable. Typically we can also refer to these as origins and insertions. So the insertions are going to be more of a movable point of attachment, whereas the origin is more non-mobile. So let's take a look at that biceps brachii just a little bit more specifically. In its proximal attachments, we have attachments to the scapula. That long head of the biceps brachii is going to attach to the supraglenoid tubercle, whereas the short head is going to attach to the coracoid process. And the distal attachment is going to insert itself on the radial tuberosity. So when this muscle contracts, we are going to move this insertion point toward the origin. So the radius is going to move toward the scapula, which results in flexion of the forearm at the elbow. And we also know that the biceps is going to supinate as well. And now we're going to talk about how we can organize our skeletal muscle fibers into different classifications based on how those muscle fibers are bundled. So the first type of fascicle organization we have is this circular arrangement. We just call these circular muscles, and this could be using the term orbicularis, or we can use the term sphincter, which when we study some of the other body systems, we'll see this term quite often. And this really helps to control material passage through an opening. So when we contract this muscle, the lumen or the opening is going to get smaller. And when we have it relax, that lumen or opening will be wider. And now for our parallel muscle fibers. These are going to be muscles that have fascicles that run parallel to the muscle's long axis. Sometimes they have an expanded central belly, and they are used for high endurance movements. And then we have our convergent muscle fibers. Here our fascicles are going to merge toward a common attachment site. So here's our pectoralis major, and all of the fibers are moving toward its tendon over here so it can reach on over and insert itself onto the crest of the greater tubercle. This can pull in a variety of directions, but not as hard as our parallel muscle arrangement. And we know this with our pectoralis major too. We have fibers going up here, we have fibers transversely, and then we have fibers that are inferior that are going to reach on up to insert into the tendon here. So we're able to flex, adduct, and medially rotate the arm at the shoulder. Next, we have our pennate muscles, and in these muscles we have fascicles that are organized as if they're part of a large feather. Here the fibers are pulling at an angle to the tendon, and it helps to generate more tension, but it's not pulling their tendons as far as our parallel muscles. So we've got three subtypes. We have our unipennate, bipennate, and multi-pennate. Our unipennate is going to be when our fascicles are on the same side of that tendon. So a good example of this would be our extensor digitorum muscle, where we see all of those muscle fibers kind of inserting along that tendon. Our bipennate type of muscle will have fascicles that are on both sides of the tendon, and this is the most common type of pennate muscle. The best example here is our rectus femoris, and you can see these fibers really well in the cadaver lab where they're moving and inserting along that tendon in the center. And then lastly, we have our multi-pennate, and this is when we have branches of tendon within the muscle and the fascicles arranged around both sides of each of those tendons. So our best example of that is deltoid, and you could see that our deltoid is broken down into these three different regions. We, of course, have that anterior, middle, and posterior deltoid portions of that muscle, and the tendon is in the center, and there are those fibers or fascicles going and inserting onto the tendon. We can also classify our muscles based on their primary actions. So the first term that we are going to cover is an agonist, which is also known as a prime mover. When we look at this example to the right-hand side here, our biceps brachii is going to serve as our prime mover, meaning that when the biceps contracts, it's going to produce a movement, which, as we covered before, is flexion of the forearm at the elbow and supination. And when we need to extend our forearm, we are going to utilize and have our prime mover be our triceps brachii over here. So when triceps contracts and causes extension of the forearm at the elbow, then it too can be an agonist. So the agonist really just depends on what movement is taking place and what muscle is causing that action to take place. Whereas the agonist is going to be a muscle that opposes the agonist. So in our first example, we had the biceps brachii that flex the forearm at the elbow. So the antagonist to that would be our triceps brachii, because it would undo the flexion of the elbow, right? By having this antagonist-agonist relationship, we are able to have smooth movements of controlled speed. Now, let's go back to that other example. What if the action that I want to take place is extension of the forearm at the elbow? Then my triceps is my agonist, but my biceps is going to serve as the antagonist, because when I perform extension of the forearm, the muscle that undoes that is the biceps, and therefore it's going to be my antagonist. And the last term we're going to discuss is a synergist. This is a muscle that assists the agonist by contributing tension or stabilizing point of origin. It can act as a fixator, basically making sure that we're going to be able to utilize the biceps in order to do that movement. So while we do flexion of the forearm at the elbow, our biceps brachii and also brachialis, which we would find down in here, are going to do that work, right? It is going to work together in order to cause flexion of the elbow. And another muscle that we haven't covered yet is Brachioradialis here, which we find in the forearm. This muscle too causes flexion of the forearm at the elbow, so it can also serve as a synergist. I want to make it clear what the term fixator is used for. We are going to have certain muscles that will help to stabilize the agonist by preventing movement at a joint. So a good example of this would be maybe your rhomboids in your back, holding that scapula in place while you perform some type of arm movement.